Hello and welcome to the Geomagic for SolidWorks webinar. My name is Greg George. I'm a product specialist with Geomagic, and we're excited to announce our new product, Geomagic for SolidWorks, the only complete integrated scan and probing solution for SolidWorks platform. Just overview before we get started of just what we're going to talk about in our webinar. Here's the schedule. The first thing we're going to do is go over what's new in our 2017 version of Geomagic for SolidWorks. We'll cover the workflow involved in our product, and then we'll go over a quick product demonstration just to demonstrate what it looks like in action for you guys. For those of you that may not be familiar with 3D systems, we offer a complete end-to-end digital manufacturing solution. And while today we're going to be covering the design and digitize sections, we offer many solutions in all of these categories that we will show today. Also, we offer solutions in the simulation, manufacturing, inspection, and management areas. And we have product offerings that demonstrate that. We are the undisputed leader in the scan to CAD solutions. For those of you that know a little bit about our history, we have over 30 years experience dealing with 3D scan data from our legacy Geomagic and RapidForm solutions. Many of the techniques and the tools that we have developed founded the techniques for the industry and have become industry standards. So how we deal with extracting parametric models and things like that. We were the first to do that and still the only people to do that in many instances. So 3D Systems has a long legacy of scan to CAD solutions, and we're excited about this next product that we're releasing here, the Geomagic for SolidWorks plugin. So as stated before, it is the only 3D scanning and probing add-in for SolidWorks. And what makes it so valuable is that you can do this directly inside of the SolidWorks environment. Obviously, you're able to leverage your SolidWorks toolset and design that you already know. Right? SolidWorks is a leader in the industry, and if we can connect the tools that we have and extend the product of SolidWorks into areas that they don't cover, that makes it a very valuable product for the customer. So what's new in this version? Geomagic for SolidWorks, we improved the sketching and the interface for better organization and enhancements for our sketching interface to make it easier for the customer. Probing device alignment, this is a great one. We allow you to align your device before collecting any information to the world coordinate system, which we'll talk about here in a little bit. And then a lot of productivity enhancements to streamline your workflow, a lot of UI, UX improved efficiencies there. So before we go ahead and talk about the workflow in a live demonstration, I just wanted to cover what the Geomagic workflow looks like. So let's just briefly talk about this. In the digitize section, that is essentially the data capture stage. So either scanning or probing information directly inside of the SolidWorks environment. That's the first step, is just collecting that information. The next step after that is the design phase. So design could be creating any geometry inside of the SolidWorks environment using their own tools, but we also give you tools to help you extract design information from the scan data, whether it be cutting cross sections or extracting extrudes and revolves and things like that. And then once you have that design information, you can verify and check it against the original scan information. So you're allowed to do a color overlay like you have in this image here that just demonstrates what you created and its deviation from the original scan data. It's nice to have that closed loop feedback to understand what might be different about the two models. And then from there, you can complete the manufacturing process. So as shown here, we have a drawing. You can take any of the geometry that we have designed and throw that into a drawing and create assemblies, throw it into your CAM package that you may have running inside of SolidWorks as well. Lots of different applications there in the complete section. But the idea there is that we're directly inside of that SolidWorks environment. So once you complete your modeling and verification process, you are in that environment and you're ready to go. So as far as the digitized section, I wanted to elaborate a little more on this. We're the only truly integrated 3D scanning and probing package inside of SolidWorks. So you can do contact or non-contact measurement depending on the device you have. Right now we support 7 different devices. There are a couple of them represented here on screen, but you can bring in data that way. Another note along the first digitization section is that we can import scan data from other environments as well. So if your scanner happens to have its own software, you can import that data, whether it be point cloud data or polygon data, into this environment and work with it without having to connect to a scanner as well. As far as the design phase, we also give you tools to help you extract model information from the scan data. In the past, I believe there have been companies that made plugins that would allow you to bring scanned information inside of the SolidWorks environment, but they fell off when they did not provide you a way to extract the information that you might need from that model. So as you see on the right-hand side, we can extract cross-sections from the polygon information and create SolidWorks geometry, or below, we actually give you an auto surface command, which we'll talk about here in a little bit during the demonstration phase. As far as the verification, just to elaborate a little more on that, you see on the top right, you have a completed model with a color map back to the scan data. So you can make decisions early in the design phase to ensure that you're creating the model that you expect for downstream manufacturing. It's nice to be able to compare it back and make sure that you are creating the model that you want to before you make one and waste that effort. So this verification process can't be understated how valuable that is to be able to check your model geometry before you keep manufacturing. And then the complete phase. Again, this is pretty simple. Once we create that geometry, it's in the SolidWorks environment, so you're free to throw it inside of an assembly, a drawing, even render it, as you can see down here below. So it's very simple, no translation or importing in order to get the data inside, because we're residing in that environment. So now let's jump over to the product demonstration section. So the first thing I'm going to do is load up a model and just talk about some of those enhancements that I mentioned at the beginning. So early on, I talked about how we can cut cross sections and how the interface is a little bit different. So the first thing I wanted to do is just create a cross-section through the polygon. So you can see here, if I grab the cross-section tool and select the plane, I can create a dimension, how far I want to offset that cross-section from its base plane. And you see here that it intersects the polygon and creates that polyline there. Now when I hit OK, it's going to create a SolidWorks sketch for me of a polyline. From that data, you can kind of see it faint in the background there. There's a dotted line. If I hide the polygon, you see that reference polyline there. And this is the manual workflow. So once I create that cross section, I can just come in and sketch anything that I want over top of that data and create a idealized version of the model directly over top of the scan data here. So if I just create a rectangle and I throw it over top of the flange there that I want to create. In this instance, I'm not going to spend time constraining all my geometry or dimensioning it. I just kind of want to show the overview of what the manual workflow is for cutting a cross section and creating sketch geometry and then extruding that. So you see here that if I just grab and create some fillets, I'm able to determine what radius that fillet is. just by visually looking at it. And then I can override and say, okay, that's a 0.65 of an inch radius, and apply that and create a nice, beautiful cross section from that scan data. Once I get out of that, this is just a SolidWorks sketch, just like any other SolidWorks sketch, except we extracted it from the scan data. And I can go ahead and extrude that up, and you can see I can use that polygon as a visual to get an idea how far to extrude it, and then hit apply there, and then you see that I created a nice extrusion from there. I can extract geometry automatically from this data as well. So what I showed at the beginning there is the manual process, but if I just want to extract a plane surface, I have all these tools over here on the right hand side, and I can just click on the polygon and create a selection, and you see it gives me a preview. When I hit apply, it creates a plane. So you see here we have some more automatic tools. So that is just for creating plane geometry. But if I wanted to extract an extrusion, which I believe is what this end piece is, I can actually say that I want to select through, and then I can change my selection tool to like this polygon selection tool, just straight lined selection tool here. And if I just look at it from the side and then create that red selection, the software automatically will calculate the direction, do an auto sketch, and preview an extrusion distance for me. And then I have the ability to edit that if I want to. So you can see I can drag these two handles out and determine how far I want to extrude that. You have different sketch options. It'll sketch in line arc splines. It'll create surfaces and solids, or just sketches. I can cut. I can create it as a new object, or Boolean it with the other one. And then once I hit OK, you see here that it creates that solid inside of space there directly over top of the polygon. You can see I can also do cylinders. So if I just want to take this cylinder here and create a manual selection all the way around the outside, you see I can select these 4 different areas, and as I do it, it gives me a preview of what that cylinder is going to be, so I can just keep adding data and let it recalculate. And you can see here that if I look at it, it appears that the cylinder is a little bit off. The direction that it's calculating is on an angle, and I want that to be constrained to that top CAD face. So I can actually tell it to constrain the direction to the top CAD face, but yet create a cylinder for me, and then I can drag out how far I want it to be, and even tell it to join it to the existing solid that's there. So you can see now that I created that extruded solid in that direction. Now, if I want to create another plane, and if I leave the solid showing, it'll change the transparency of the solid for me. And now when I fit a plane to this top surface, I have the ability to create a trim plane. So I can say that I want this plane that I fit from scan data to cut away from the original solid that's there. So you see here I can change the enlargement, and then it'll automatically create that plane and then cut it away from the solid. And then from here, intermixed with the tools that I'm using inside of SolidWorks, I can just jump over to the SolidWorks tools and say that I want to throw a fillet on that edge. And then it makes it very easy to visualize. If I just type in 0.3 there, it looks like it's about a 0.3 fillet. So as you can see here, I've modeled all these features here. I'm not going to spend the time to model everything, but if I come over to the deviation tool, as I mentioned before, I can select what polygon and what CAD body that I want to use to create a comparison between the two and give me feedback as to how closely I modeled it. So you see here, through the casting process, I think that the fillet has changed a little bit. You can see here that it varies, but I applied a constant fillet all the way around. So you can see that deviation, and it tells you that. And you have the ability to then make decisions based on that design process. And remember, everything in here is fully editable. So if I come over and just click on that sketch and go normal to and zoom in, this is native SolidWorks sketch information. So I just want to make sure you know that. And then if I zoom in there, you see that it has the reference polyline available too, to allow me to see where these. For the next part, I wanted to show how you could hard probe and scan in the same space inside of our environment. So on the left-hand side, we have our data collection tools. In the middle, we have our scan editing tools. And on the right-hand side, we have our extraction tools. So the first thing I'm going to do is hit connect and connect to this device. And I'm going to go ahead and I'm going to probe data that I want to use for alignment to the world coordinate system. In this instance, I picked a nice simple part where I could probe 3 different planes and just show the basic concept here. So I'm going to probe a top plane, a side plane, and another side plane. So if you think about this, it's like working with an assembly, except for I'm capturing the data's location to start out with. And these 3 planes represent where the part currently is. And then if I come over to Orient Device, I can select these 3 planes, and it'll give me the ability to tell it that move those 3 planes in the coordinate system they form to the world coordinate system. So now if I go back and scan, I'm going to scan directly into the CAD package's coordinate system. So as you see here on screen, I'm scanning, and it'll make more sense here in a second what this part is and how it's related to the world for CAD for the CAD package's coordinate system here. But what you're seeing on screen is actually a bunch of point cloud. It's a point cloud. Thousands and thousands of points closely related to each other, and when you see them next to each other in such a high resolution, you can get a picture of what the object looks like, right? So if I was to throw this many points inside of SolidWorks in a normal instance, SolidWorks would not be able to handle this many points, but our software platform in the background is doing all the heavy lifting of managing the high density point cloud here. So we color the points green just so you could tell based on what color the data is, what type of information it is. So the green color represents point cloud, and you see the back side of the points actually has a gold color to it. You can kind of see it when you look through the points there. And the reason why that's the case is we actually know which direction the points are collected from. So we have a normal direction, and we can tell the point cloud has an inside and an outside, so it makes it a lot easier to visualize and even apply rendering to it, and makes it very easy to see what the scan data looks like. If you've ever worked with a point cloud where we didn't have normal information, you would notice that all the points appear black and there's no rendering applied to it. It makes it very difficult to see what you're looking at. So now that I have all that scan information, you can see I can rotate around. I didn't scan everything. And that's one advantage to having a probing device and scanning device is I don't have to see everything because I can always go back and I can probe features, and I just wanted to demonstrate that. The first thing I'm going to do is take the point clouds, and you'll see that I have 25 different point clouds. Every time I pulled the trigger on this device, it created a separate point cloud. And what I'm going to do is optimize the alignment between those two, which shuffles them around and removes any alignment error that might be between the point clouds. And then I'm going to go ahead and I'm going to merge those together. So merging in this software will allow me to take all of those data sets and merge them into one object. And in this instance, I'm telling it to give me a mesh object. So right here on screen, now what I have is a triangle mesh object. The first thing I usually do is I will run the repair tool. Sometimes you get some artifacts and things when you're scanning. We've built tools to automatically repair those for you. We have years and years of experience in the printing world and polygon editing world to automatically remove those things. The next thing is to go ahead and edit this. So I just wanted to show that if I wanted to, I could come in and edit this mesh feature inside of the SolidWorks environment. and just crop information away, right? So I'm able to just window in and select and just say, maybe I don't want this area, maybe I don't want that area, and manipulate the information. You see on the left-hand side, you get all the data about the polygon over there. Now, if I come back and I say that I want to probe some features, you'll notice that they all come in relation to the scan data that I've already collected. So if I probe that side plane right there, and then I probe this back plane here, you'll see that it creates native SolidWorks CAD surfaces from this geometry that I probe. So if I probe those 3 planes, and then I just back up here and hit the checkbox, you'll see that it goes back and makes those surfaces for me. Now, if I come right back in and I turn on the reference planes, you'll see that it is related to the CAD coordinate system. And if I want to probe a slot, I have a bunch of different options as to what plane to put it on. I can reuse a plane, probe a new one, or probe select one. But in this instance, what I'm going to do is just say that I want to probe a plane, and I just probed one there. And then now I want to probe this slot. And what this is going to give me is a sketch of a slot on top of that plane that I selected. So you can see there, if I zoom in and rotate around, that we're able to probe that slot instead of spending all the time to scan down in that area. Now, if I reuse that same plane, I can also probe other sketch entities. In this instance, probing a spline would be really handy. So that area that I missed on the side, if I just come back and say that I want to probe those spline entities there, I just probe all the way around the outside and hit OK. Now that if I rotate around and look in, you'll see that it created a sketch feature with a spline fit to those probed points that I collected. So that's a really valuable tool to be able to have there. So the next thing I wanted to do is on the back side, there is an audio jack for this guitar. With the Telecaster, there's a famous jack on the bottom. That's where they put it. And there is a bored hole that goes up into the control cavity that we probed with a slot. It's an occluded area that may be a little difficult to scan. So one benefit of having the hard probe device is that I can probe the cylinder on the back side over there, and if I rotate it around, you'll see that it probed a surface body from that audio jack that's on the bottom of the guitar. So that's all I wanted to show with this model here. I have another workflow that I wanted to demonstrate that's more along the lines of an organic-based workflow. So on the left-hand side, you can see that I have the ability to import information as well. I don't have to collect data directly inside of the SolidWorks environment by scanning directly in. I can import mesh information or point cloud information from almost anywhere. So if somebody sent me a mesh file like this of somebody's anatomy, I would be able to just import that in and use all the same tools that we built in here for the plugin, but on that type of information. So the first thing I'm going to do is harness one of the most powerful tools in here, this auto surface tool. So if I have a highly organic shape, that's what this is really powerful for, I feel. I can throw a scan data set in here, tell the software to automatically fit surfaces to it. Now this is a bounded shape, so when our plugin finishes, it's going to create a bounded surface object, which is a solid. So you see here, if I go ahead and rotate it around and then turn off the mesh, that it created a CAD body from that mesh information automatically. As you guys know, it would take a long time to capture the exact shape of this arm by modeling it with surfaces on your own. Now the surface of this part is very organic, and the structure of the patches is very organic. What I'm going to do is go ahead and put a plane on top of this hand here, and I'm going to just select those vertices, and I'm going to come back and draw a spline, and I'm just going to trim the CAD body back to just the area that I want to work with. So if I'm just going to draw a shape here, just how I want to crop it. And when I hit OK and rotate to the side, you'll see that I can just go ahead and do a surface extrude. There's a whole host of different ways of doing this, but in this instance, I'm just choosing to use a surface extrude, and I'll just do a cut with surface and trim this down to a smaller piece that I want to work with. So if I hit OK there, and I rotate the part around, I can just say I want to cut with surface. Just change the direction and hit OK. So now I'm going to hide that construction tool. And then I'm going to take this solid body and delete the faces and make it a surface body. And then from there, what I plan on doing is creating a brace from this anatomy. So there's lots of different applications. A lot of education world, a lot of medical world uses scan data all the time to create pieces that fit people's anatomy exactly. And I feel like scanning and CAD are a great pairing to be able to work with those types of applications. So in this instance, what I'm going to do is I'm going to draw directly on top of this surface with a spline on surface tool that SolidWorks offers here. So it'll just take a second for me to segment it out, but I really feel like this application is worth showing because it's one of those interesting applications that we've done with this product many times before, and we feel like it's got a lot of benefits. So if I just draw the two different splines here that are kind of the starting point. So what I want to do is make the brace wrap around the inside of the wrist and come around the back side of the hand and then go down and connect into the palm. So bear with me as I sketch this out for a second, because I really feel like it's a valuable workflow. It's very interesting to be able to bring in data like this. And there's a lot of other things that I believe you could do with this type of tool that make it so valuable. So as you see here, I'm just going to rotate it around and then make it connect to the other side. So I'm just going to look at it from this direction and make sure that I'm going to connect it to this side right over here. And then I just close that spline. And then after this, I'll just create one more, and we will have our brace segmented out. So the way I plan on doing this is as I draw this last spline, I'm going to take this curve and I'm just going to do a trim with curve in the surface trim tool. And there are a variety of different methods, again, that you could come up with that might be better depending on the specific application or the specific anatomy, what it looks like. But in this instance, I'm just going to use the curve to trim the surface of the part. And then I'm going to use the thicken tool to create the brace from there. So you can see here, if I just draw it all the way up the back side there, if I wanted to, I could always do extrusions from different directions and intersect those with the CAD surface if I wanted to. But in this instance, I'm just doing a very quick overview. So if I come over to trim surface, and I'm going to click on trim surface there and select standard and the curve that I got. And I'll just click the side that I want to keep. You'll see that I have a trimmed piece now. And I'll just hide the segmentation of the surface and rotate it around. So you see the power here now. If I just come back and use the thicken tool and apply a distance, whatever distance it happens to be, whatever thickness I want to use, I could thicken this and create the piece. Now, with this type of object, you can do anything that you want to do with it. So if you wanted to come back and print this piece, you could do that. that happens to be a very good way. You could use an SLS type print, and it would have a very strong strong material properties to create a brace from. So you see here, if I rotate it around and look at it from different directions, we just created a brace that fits that anatomy exactly. So that's a really valuable workflow. So that's all I had to show for today. I figured I would show a few different things that were new and some different applications. And we're really excited about the new product, the new version of Geomagic for SolidWorks. If you guys have any questions, feel free to reach out to your local reseller or your local 3D Systems Geomagic account manager or product specialists, and we're happy to answer or do demonstrations for you. So thank you for your time, and we look forward to working with everybody.